Have you ever gazed at the night sky and wondered if we're truly alone? The universe is vast, billions of galaxies, stars, and planets. For generations, we've asked, are we alone? This is the heart of the Fermi paradox, a contradiction between the high probability of alien life and the utter silence we observe. Our galaxy alone has hundreds of billions of stars, most with planets, many in the habitable zone. With so many chances for life, the universe should be teeming with civilizations. Yet, when we listen, we hear only silence, a cosmic quiet that's both haunting and profound. Where is everybody? The numbers say life should be everywhere, but our instruments find only emptiness. This isn't just a scientific puzzle, it's a question about our place in the cosmos. So let's explore the possibilities. Are we truly alone, or is something else at play? To understand the Fermi paradox, we must first grasp the staggering scale and richness of the universe we inhabit. When we look up at the night sky, we're seeing just a tiny fraction of what's out there, an ocean of stars stretching far beyond what our eyes can perceive. Our own Milky Way galaxy, alone, contains hundreds of billions of stars, each one a potential sun, each with the possibility of hosting its own family of planets. The sheer number is almost impossible to truly imagine. And the Milky Way is just one galaxy among trillions. Every patch of sky, no matter how small, is filled with galaxies, each containing billions or even trillions of stars. The universe is a vast cosmic tapestry, woven with countless opportunities for life. Thanks to powerful telescopes like Kepler and James Webb, astronomers have discovered that planets are not rare at all. In fact, most stars are now believed to have planets orbiting them, some with entire systems of worlds. Many of these planets orbit within the so-called habitable zone, the region around a star where temperatures are just right for liquid water to exist. Water, as we know, is essential for life as we understand it. The basic ingredients for life, water, organic molecules, and energy, seem to be scattered throughout the cosmos. From the icy moons of our solar system to distant exoplanets, the building blocks of biology are everywhere we look. Enter the Drake equation, a scientific tool designed to estimate how many civilizations in our galaxy might be capable of communicating with us. It's a way to turn cosmic wonder into a mathematical question. The equation multiplies together a series of probabilities. It considers the rate at which stars form, the number of planets per star, how many of those planets could support life, the chances of life actually arising, the odds of intelligence developing, the emergence of technology, and finally, how long such civilizations might last. Each factor is a piece of the puzzle, and even with cautious estimates, the numbers quickly add up. Even if we're pessimistic, the math suggests there should be thousands, perhaps even millions of civilizations in our galaxy alone, each potentially sending signals into the cosmos. Yet, despite decades of searching, we see and hear nothing. Our instruments scan the skies, but the silence is profound. Maybe life is common, but intelligence, at least the kind that builds technology, is incredibly rare. Perhaps we are the exception, not the rule. Or perhaps civilizations, once they arise, don't last long enough to overlap. They may destroy themselves, or simply fade away before contact is possible. The numbers promise a universe teeming with life, but reality gives us only silence, a cosmic mystery that deepens with every new discovery. The Fermi paradox is the gap between what we expect to find and what we actually observe, a universe that should be alive with signals, but remains eerily quiet. Why is the universe so quiet? The question lingers, inviting us to keep searching for answers among the stars. Maybe the numbers deceive us. When we look up at the night sky, we see billions of stars, each with the potential to host planets. It's easy to imagine that life, even intelligent life, must be common, but what if that's just an illusion born from the vastness of space? The rare Earth hypothesis suggests complex life is incredibly rare, even if microbes are common. Simple organisms might thrive in many places, but the leap to animals, plants, and intelligence could be far more difficult than we realize. Earth's habitability is the result of a series of cosmic coincidences, a stable star that burns steadily for billions of years, providing just the right amount of energy for life to flourish. A safe spot in the galaxy, far from deadly supernovas and cosmic radiation, nestled in a region where conditions are just right for life to persist. A giant planet like Jupiter acts as a cosmic shield, deflecting asteroids and comets that could otherwise wipe out life in an instant. And a large moon, unique among the planets, stabilizes our planet's tilt, keeping our climate relatively stable over millions of years. Plate tectonics regulate our atmosphere, recycling carbon and maintaining temperatures suitable for life. Without this geological activity, Earth might have become a frozen wasteland or a scorched desert, and evolutionary leaps, like the rise of complex cells, or eukaryotes, may be flukes, the result of rare mergers and accidents that could take billions of years to repeat, if they ever do. The Cambrian explosion, which sparked animal diversity, might be a once-in-a-universe event, a sudden burst of innovation that set the stage for all complex life. Add it all up: the right star, the right planet, the right moon, the right chemistry, and the right timing. Each piece is essential, and each is rare, and a string of lucky evolutionary breaks, each one building on the last, leading from simple molecules to thinking beings. The universe could be full of microbial worlds, teeming with simple life, but complex, intelligent life might be vanishingly rare. Perhaps so rare that we are the only example for light years around. We may not be cosmically special, but we could be cosmically precious, a singular oasis of consciousness in a vast, silent universe. Perhaps the chain of events that led to us is so improbable, it hasn't happened anywhere else, or at least not yet. We might be the first, or the only intelligent civilization in our galaxy, carrying the torch of awareness through the darkness. It's a lonely thought, but it gives our existence immense significance. If we are alone, then every action we take matters even more. If we're rare, our responsibility to protect life on Earth is even greater. We are the stewards of something truly unique. The silence could mean we're a cosmic miracle, a testament to the universe's potential for wonder, or just a cosmic accident, an extraordinary fluke in an indifferent cosmos. Either way, our story is worth cherishing. There's a darker possibility, the Great Filter. Somewhere on the path from simple life to advanced civilization, there's a nearly impossible hurdle. Maybe life rarely begins, or complex cells almost never form, or intelligence is a cosmic fluke. If the filter is behind us, we're lucky survivors. But what if it's ahead? Maybe civilizations inevitably self-destruct, through war, environmental collapse, or runaway technology. Nuclear war, climate disaster, or rogue AI could be universal pitfalls. The silence could be a warning. Most civilizations don't make it. If we find simple life elsewhere, it might mean the hardest steps are still to come. The empty cosmos could be a graveyard of failed civilizations. The Great Filter asks, have we already passed the test, or is our greatest challenge yet to come? The silence is a message. Don't repeat their mistakes. Our future depends on whether we can avoid the fate of those who came before. The paradox is not just about aliens, it's about our own survival. What if we're not alone, but being deliberately ignored? Enter the zoo hypothesis. Advanced civilizations might be watching us, choosing not to interfere, like biologists observing animals in a preserve. They could be waiting for us to reach a certain level of maturity before making contact. Or maybe they're protecting themselves, hiding in a dark forest where silence is survival. Broadcasting our presence could be dangerous if the galaxy is full of silent, cautious civilizations. Perhaps we're simply beneath their notice, like ants to humans. To a civilization millions of years ahead, we might be irrelevant. The universe could be buzzing with activity, but we're firewalled from it until we're ready. Or maybe we're living in a simulation with reality carefully hidden from us. The silence could be intentional, a cosmic do not disturb sign. Whether for our protection, theirs, or out of indifference, the result is the same: apparent emptiness. We might be in a galactic zoo waiting for the day we're allowed to join the conversation. Until then, we're left to wonder. Maybe the problem is us. Maybe, despite all our searching, we're simply not asking the right questions, or looking in the right places. We assume the universe should be easy to read, but what if it's written in a language we've never even imagined? What if the universe is full of signals, but we're not equipped to detect them? Our instruments are tuned to what we know, but the cosmos might be humming with messages on frequencies we've never thought to check. We search for radio waves, hoping for a familiar hello. But advanced civilizations might use technology so far beyond us that we can't even conceive of them. Our tools, impressive as they are, might be as primitive as smoke signals compared to what's really out there. They could communicate with quantum particles, neutrinos, or gravitational waves, methods invisible to us, slipping right through our detectors. Imagine entire conversations happening in forms of energy or matter we haven't learned to sense. We look for life as we know it, but alien life could be utterly different. Silicon-based, plasma clouds, or even post-biological machine minds. Life might not need water, or DNA, or even bodies as we understand them. Civilizations might upload themselves into vast computational structures, living in ways we can't recognize. Their entire existence could be digital, their thoughts encoded in patterns we mistake for cosmic noise. Their messages could be subtle changes in starlight, not radio beacons. Maybe they're engineering stars, or modulating light in ways that only make sense if you know what to look for. The universe might be filled with life, but it's functionally invisible to us. We could be surrounded by civilizations, each hidden behind a veil of unfamiliar physics or biology. We're searching for little green men, but the reality could be star-sized brains, or data streams, vast intelligences operating on scales and in forms we can barely imagine. The silence may be an illusion, born of our own limitations. We might be like fish, unable to comprehend the world above the water, mistaking our ignorance for emptiness. The cosmos could be a library, but we don't know the language or where to look. We're surrounded by knowledge, but without the key to unlock it, every page is blank. The challenge is not just to keep listening, but to learn how to listen differently. We must invent new ways to sense, to interpret, to imagine what's possible. The Fermi paradox might be a mirror reflecting our own technological infancy. It's a reminder that our understanding is still young, and the universe is far older and stranger than we can grasp. The answers could be all around us, waiting for us to evolve, not just in technology, but in imagination, curiosity, and the courage to see the universe with new eyes. The Fermi paradox is more than a scientific riddle. It's a mirror for humanity. In asking, where is everybody, we're really asking, what are we? The silence could mean we're rare, and that makes our existence precious. If we're alone, our survival matters, not just for stores for stores, but for the universe. The cosmos may be silent, but that gives us purpose, to protect life, to seek understanding, to be worthy of our improbable existence. We may never know the answer, but the search itself is vital. So keep looking up, keep asking questions, and keep exploring. In searching for others, we may discover the true measure of ourselves.